Alright, this is a video on factoring. We're basically going to review the first part of Unit 8. Things to remember with factoring is one, you always want to look for a GCF. Otherwise known as the greatest common factor. That is the first thing. Oh, my handwriting is poor on here, I'm sorry. Look for greatest common factor. Okay? That's the first thing you're going to do. And then you're going to just go from there. So let's start off with some simple ones. Okay, so if we look at this, we're going to have two terms, and we look to see if we have a greatest common factor. Greatest common factor is a number that goes, or a variable that is in each term. So it has to be in this term and also in this one. So if I look at these two numbers, I have a 4 and an 8. Well, the factors of 4 are 1 and 4 and 2 and 2. The factors of 8 are 1 and 8 and 4 and 2. So the largest number they have in common is that 4. So I'm going to write that down. That's my GCF. I have an x squared and an x. You always want to take out, if you're never sure which one you're going to take out, you're always going to take the one with the smallest exponent. In this case, this is the x. So I'm going to take out the x. So now that's my GCF, is 4x. To figure out what's left, I have to say to myself, okay, what times 4x gives me 4x squared? Well, what times 4 gives me 4? That's just 1. I have 1x. I need 2, so I need 1 more. What times 4? Now we move on to the second term. What times 4 gives me 8, and that is 2. So there's my factors, a 4x and an x plus 2. Please remember, a greatest common factor, a GCF, is still a factor. So if that's all you can do, you've factored the problem. Okay. So this one is done. So let's look at another one. Okay, and this is called a trinomial because it's got 3 terms, tri meaning 3. So what we're going to do is we're going to again look for a GCF. Well, I have a 1 in front of the x squared, a 5, and a 4. They don't have any common factors. So we don't have a GCF this time. So we're just going to do a diamond problem in our generic rectangle. Now the way I set up my diamond problem is I'm going to rewrite my original problem down here, because I find that students have, the biggest problem students have is to know so with our diamond problem, what I do is I rewrite the problem, and then I actually put my diamond problem right over the top of my original, like this. Alright, so now I figure out the top, the x squared times the 4 goes up here, and that's 4x squared. So I'm looking for numbers that multiply to be 4 and add to be 5. Now this is, I use really small numbers here, so probably thinking, okay, no big deal. But if you start realizing you can't figure out what multiplies, the best thing you want to do is take the number on top, so that 4, and off to the side write the factors out of 4. So in this case it's 1 and 4, or 2 and 2. And see if you can get any of them to add to be that 5. Well, I can see that it's the 1 and the 4. So I say 1x and then that 4x goes here. Now what this allows me to do, the way I've set this up, is when I go to do my generic rectangle, I can do what I call go over the mountain. So I'm going to start with the x squared hold on here. The x squared goes in the first box. Then I go up to the 1x. The 1x goes in the second box. The 4x goes in the third box. And the 4, sorry about that, goes in the last box. Because what I find is students try to always place that value at the top of our diamond problem into our box, and it never goes in there. And so that'll mess you up if you try to do that. So if you go over the mountain by using your x squared, your 1x, the 4x, and the 4, you'll be able to fill in your box. Now that we've filled in the box, what are we going to take out? On top, I have a common factor of x. So I'm going to take out an x. And then I have to say to myself, what times x gives me x squared? Well, that's another x, so that goes on top. What times x gives me 1x? Just a 1. Now there's two ways to do the bottom. You can look for a GCF on the bottom and pull that out. The thing to remember is if your first one is negative, you have to pull out the negative. Or you can look from the top and say, what times x gives me a 4x? And that is a 4. So now I've factored it, and my factors are x plus 4, x plus 1. Okay, we're going to do 2 more examples, and then we're going to be done. So for this first example, let's look at, okay, so our example is going to be 6x squared, or excuse me, 6x cubed plus 15x squared minus 36x. Now if I look at this and I try to do, if I were to want to do a diamond problem, I'm going to have 6 times 36. And that's 216. That's a huge number. Whenever you get numbers that big, you're probably got a GCF. So let's look to see if we have a GCF. Well, I have a 6, a 15, and a 36. 3 can go into all those, so I'm going to pull out the 3. But now look at the other ones. I have an x cubed, an x squared, and an x. I cannot do a diamond problem if I have an x cubed. It doesn't work. So I got to get rid of that x cubed. And since everything's got an x, I'm going to pull out that x. Well, now I just factored out what times 3x gives me 6x cubed. That's 2x squared. What times 3x gives me 15x squared. That's 5x. What times 3x gives me negative 36x? And that's negative 12. Okay. Okay, so let's continue. So this 3x, it's a GCF. It's not going to do anything. It's already done its job. We just can't forget about it. Alright, so the GCF it's already done its job, we just leave it alone. So I'm just going to write it off here to the side. And we're actually going to factor what's left in our parentheses. So I'm going to make my diamond problem. And now I take 2 times negative 12, and that's negative 24 x squared. So I got to figure out what multiplies to be negative 24 and adds to be 5. And I'm going to actually list the factors out so that you get used to seeing that. So I know 1 and 24 does it. Well, that's not going to give me a 5 if I subtract them. 2 and 12. Nope, no 5 yet. 3 and 8. There's my 5. So 3 minus 3 from 8 gives me 5. So I need a negative 3x and a positive 8x. I'm going to make my box. And okay. Remember, we have to go over the mountain. So the 2x squared, the negative 3x, the 8x, and the negative 12. Those are the 4 items that are going to go into your box. So 2x squared goes in the first box, negative 3x, 8x, and negative 12. So looking at the top, what can I take out of the 2? Well, I have a 2 and a negative 3. There's not a factor that's in common between those two, but I still have my x. So I'm going to pull out my x. And now what times x gives me 2x squared? Well, 2x. What times x gives me negative 3x? Negative 3. Now going vertically, what times 2x would give me 8x? Well, that's a positive 4. Okay, so there are my factors. So now to write all this out, that 3x we can't forget about it. It's got to come down in front. And that's a mistake a lot of students make, so make sure you don't do that. 2x minus 3, x plus 4. Alright, that one's factored. Now the last one we're going to do is really simple, but students seem to mess up on it. Now, the thing to remember, the only time you can make that you're going to be able to do more than just a GCF is you have to have an x squared. So the next one has the x squared, but it doesn't have a middle term. We only have 2 of them. So I have a 9x squared minus 16. Well, there's no GCF in this one. Sometimes there is. Sometimes we can take one out. But this one is actually a very special pattern. We're not going to use a box on it. We're not going to use a diamond problem. Well, if I look at it, well, what multiplies to be 9? Well, for 9x squared, that would be 3x and 3x. So this is something that's called a perfect square. Well, let me look at the other number. 16. 16 is also a perfect square because it's 4 and 4. Now, because this was a negative 16, one of them's got to be a negative 4. Well, these are my factors. I just take one of each, so 3x minus 4, and that's one of my parentheses. My other parenthesis is the other 3x, this time with the positive 4. And that one is factored. And that's all you have to do. Alright, so this video is done. This is our review of factoring. If you have any questions, make sure you talk to your teachers in class.